Good morning, everybody. So here's our first lecture on parabolas, and this is going to be separated into two videos, so today and tomorrow, Tuesday and Wednesday. Now there's homework on my math lab for this, and we have 5 examples to go through. We'll just do 3 today and the other 2 tomorrow. So first of all, you know what parabolas look like. This is actually taken from page 565 of your text, and let me back up one page here. This section is called conic sections. And if you imagine 2 inverted cones and then take a cross section, you get 4 conic sections. If you take a cross section right here, you get a parabola. If you go through the entire cone, but just one cone, you either get an ellipse or a circle. And if you take a cross section of both cones at the same time, you get what's called a hyperbola. So those are 4 different shapes you can get from taking a cross section from a cone, and those 4 shapes are called conic sections. And so we're going to start with parabolas. And I know you know a lot about parabolas already, but we're going to add a lot to what you already know. First of all, parabola can be defined by distance. Like a circle can be defined by distance. A circle is just a set of ordered pairs that are equidistant from another ordered pair. We call that the center. Well, a parabola can be defined by distance. All these ordered pairs are equidistant to a point called the focus and a line called the directrix. Excuse me. So here's one example. This is one point on the parabola. Whatever this distance is to the focus and whatever this distance is to the directrix, this line is the directrix, those 2 distances are the same. And that's true for every ordered pair. So here's another ordered pair. If I took my ruler out and measured that distance, and then took the ruler and measured that distance, they would be the same. So all possible distances that are the same to the focus and to this line would create this parabola. And there are just a couple of new things. This is called the focus. We already know what the vertex is. So the 2 big additions are the focus, which is just one point, and the directrix, which is a line. And the distance between the vertex and the focus is called the focal length. And this purple line, this is called the focal width. So like how wide is the parabola? But the parabola's width could be, this section is wider than this section. So we all have to agree that when we talk about the focal width, it's the width of the parabola that goes through the focus. Now, when you take your quiz or you take your test, you're going to be allowed to have notes, and this is going to be what you're going to be allowed to have. But I really believe that if you do all your homework, you're not even going to need this. So I would suggest do all your homework and take this, and you're going to find, I doubt you're going to look at this or maybe just glance at it. But this will tell you, this is kind of like your legend, your map. It'll tell you everything you need to know about parabolas. First, these are the only 2 we'll study, the ones going up and down, the ones going left and right. And notice they both have a vertex, which is HK. And the other point inside of it is called the focus. And notice if it's facing up or down, it's the focus has the same x value as the vertex. It's just p more up. So you would add p to the y value. And then and we'll have to find out what p is, just like we'll have to find out what h is and what k is and all that stuff. So this has a focus too, and it's also p away. But notice p is being added to h. So you would add p to the x value. So you would go further to the right or further to the left because p could be negative. So just like these parabolas can be facing up or down, these can face left or right. And also notice, I hope you're noticing that we're not talking about functions anymore because this is not a function. It's not a function of x. It's a function of y, but regardless, we're not going to be using the function symbol anymore because most of these conic sections are not functions. This is what's called standard form of a parabola, and it looks different than anything you've seen. And again, you're going to have this on your quizzes and tests, and you've got x and y, which generates all possible ordered pairs. That actually generates the parabola. HK is a specific point. That's the vertex. So those are going to be numbers. And P, remember, that's the value. How do you get to the focus? Also, it tells you the focal length, because the distance between the vertex and the focus is you're just P away, and that's the focal length. The focal width is, we're told, it's 4 times P. So that whatever, if I want to find the focal width, I just need to know what P is and then multiply it by 4, and that's the focal width. Same for facing left and right. And the directrix, remember, is a line, and this directrix would be just opposite this parabola. So every ordered pair in this parabola is the same distance to the focus as it is to the directrix. This directrix would be facing up and down. Every ordered pair in here would be equidistant to the focus as it is to the directrix. So notice on the ones that are facing up or down, the directrix is y equals. It's a horizontal line. But if it's facing left or right, the directrix is x equals, a vertical line. All right, and I think it's definitely best to do these problems to practice. So our first example, we're going to find the focus, the directrix, and the focal length. So the focus, the directrix, and the focal length, these 3 things of this parabola. And notice how it's x squared. Also in the standard form, only one of the things is squared. And the up or down, the x is going to be squared. On the left or right, the y is going to be squared. So since I know the x is going to be squared, I'm not even going to look at this. I know that it's facing up or down. So my entire focus is on this portion. So my goal is to figure out, I need to know the focus, the directrix. I need to know K and P and H. I need to know H, K, and P. So I'm going to try to make this look like the standard equation. And it first begins with me multiplying by -5. So it gets this, -5y equals x squared. And I can, the equal sign is symmetrical, so I can just write it on the left side because I'm really trying to make it look like this. And x squared is the same thing as x minus 0 squared. And y is the same thing as y minus 0. So can you see that now I've made this look like this, and it really matches what the standard form looks like. So now I just pluck out information that I need. I know that h is 0. This is h. K is 0. What about -5? Well, -5 is in this position, right? So -5 has to be 4p. And if -5 equals 4p, then p is -5/4. So now I know everything. I know h, I know k, and I know p. And what am I supposed to do? Find the focus. Well, the focus is h, comma, k plus p. So it's 0, comma, 0 plus -5/4. There's the focus. I need to find the directrix. The directrix is y equals k minus p. So I know k is 0, p was -5/4, so y equals +5/4 is the directrix. And the focal length is 4 times p. Well, the p value is -5/4, and it's the absolute value of that, remember? So the 4's cancel out. It's the absolute value of -5, so it's just 5. So there's our first example. We have this parabola, and with the help of our notes, we can find the focus, the directrix, and the focal length. Example 2. Again, we've got our note card right here. Find the equation in standard form. So I'm finding one of these two. What do I know? I know that the directrix is x equals -3. So right away, the directrix is x equals something. So I'm not talking about this one. I'm talking about a parabola that goes left or right. So I know the directrix is x equals -3, and I know the focus is -5, 0. Okay, well, according to my map, x, the directrix, is h minus p. So since the directrix is -3, h minus p must be -3, right? And the focus is negative 5, 0. Well, the focus is h plus p comma k. So this tells me that k must be 0 and h plus p must be negative 5. Now what? Well, I know that h minus p is negative 3 and h plus p is negative 5. I can combine those into a system of equations. H minus p equals negative 3, h plus p is negative 5. I can add both of those up, and the p's would cancel out, giving me 2h equals negative 8, and h is negative 4. So I know k is 0, I know h is negative 4, and that tells me that p is negative 1, because if h is negative 4, I can go back to either of these two equations. Negative 4 minus negative 1 will get me negative 3. So now I know everything. I know k is 0, I know h, and I know p, and that's enough for my standard equation. So I just type in everything I know. K is 0, p is negative 1, h is negative 4. Clean this up a little bit. Y minus 0 squared is just y squared. 4 times negative 1 is just negative 4, and you got the x plus 4. So let's look at Desmos really quick. So here is our parabola, and there's the focus, negative 5, 0, and the directrix. All we were given was the focus and the directrix. And you see how every ordered pair in this parabola is equidistant to the focus and the directrix. And this is the p-value right here, p-value of a distance of 1. So that's the focal length. And let's go back. Let's try to squeeze in our last example, example 3. So we'll do the next two tomorrow. Find an equation in standard form. Okay, another thing, we have to find the standard form of a parabola with a vertex of negative 5, 6 and a focus of this. Okay, so the vertex and the focus. Look at the vertex and the focus. Here's the vertex, here's the focus, or maybe it's this vertex and this focus. Well, you see how the x values are the same? The x values are both negative 5. Which one of these two does that occur in? It occurs in this one, the one that's facing up and down. So based on this little clue, I know we're not talking about the movement of left and right. We're talking about a parabola facing up and down. Okay, so the vertex is negative 5, 6. Right away, the vertex is hk. So I know h and k. H is negative 5, k is 6. That's really helpful because in standard form, I need h, p, and k. And I already know h and k. How do I find p? Well, I need the focus. The focus is h comma k plus p. And I know the focus is negative 5 comma 3. So h, I replace h with negative 5. I knew that. And I knew k is 6. And so what does p have to be? P would have to be negative 3. That's the only value that would make 6 plus p equal positive 3. So I'm done. I've got h, I've got k. They were given to me in the vertex, and I had to do a little bit of math to find p because I knew the focus. P is negative 3, and now I plug them all into here. So x minus negative 5, 4 times negative 3, etc. And here is my standard form.